Hey, everybody. Excuse me. My name is Lester Martin. I am from Starburst, and today we're going to do a webinar. Hopefully, I'm all there live. Yep. Hopefully, we see my messages. Hopefully, folks can hear me. I'm running solo today. My my co-pilot stepped away, and I don't have my AI co-pilot doing all the work for me, I guess. And I have a bad cough. So, one last time, thank you. I think I have it cleared. All right, so this webinar is going to be pretty darn awesome, I have to say. I'm just adjusting a few screens and make sure. There we go. I can see the chat way over yonder, and off we go. Turn all these little buttons off. Come on. Hey, low connection for before content. Really, the only thing I would take from this, besides a good-looking picture of a good-looking guy that used to have some hair, is that email address at the bottom, devrel@starburst.io. I gave you some links of other ways to reach out, a forum site. There's lots of other good ways to reach out, including the Slack for Trino, lots of cool, exciting places. And the Dev Center as well. Hey, Ravi, nice to meet you. Hey, we'll leave it on screen just for a few seconds. I'm going to take it away. No big deal. It's a Trino Iceberg cheat sheet if you're interested in those kinds of things. If you don't get it now, we can catch it at the end. I'll hang around and give the link out to that as well. Some folks from India as well. All right, so if we're going to have a conversation around, what's it called here? Iceberg metadata, then why don't we just take a minute and make sure we agree what Iceberg is, and we'll jump on in. This is I would call it not an intro session. It's more of an advanced session, but I do have some couple slides. Definitely are from Glasgow. Nice to meet you, Charlotte. Lots of good places from Italy. I was just in Italy, Alessia, just 2 weeks ago. My wife and I went to Rome and Naples. We only had a week, so we only could go there. Had an incredible time. Okay, Apache Iceberg. And, I work for Starburst, so we're talking about Starburst. But absolutely, Iceberg needs table formats. Those table formats, those files, file formats, such as Parquet, what we'll think about today, but Orc and others. And that sits on top of some kind of object store. That's our center of gravity. There's that table format of Iceberg. Remember, comparisons are Hootie and Delta Lake and Hive. And then, of course, our engine, trying to fit in Iceberg with Starburst. So Starburst is built around the open source project called Trino. So absolutely. Nashville, that's not too far from my house. Good. I'm glad everybody's commenting. Thank y'all for that. And then Starburst and Trino, we access lots of other stuff too. Didn't have to just be data lakes, databases, search engines, all kinds of NoSQL systems, even applications and whatnot. So Iceberg and Starburst fit together nicely. Yeah, then absolutely we have some wrapper stuff around all that stuff and really important and critical. But what we're talking about is Iceberg, and just to remind us what I think gives Iceberg a lot of value beyond transactioning and the snapshots, all that cool stuff we're going to see. The metadata is just this, where the premise and the promise is around multi-engine support. I also say, hey, Renee from Marietta, I'm over here in Milton, so nice to meet you. The trick, I think, is around the catalog more than the table format. So we can have that another conversation. It's something I and many others said a year or two or three ago. It's not as much about the table format it is, but then it's really about the catalog, especially for Iceberg. But absolutely, this is what we're hoping and shooting for. All right, let's get into it. I am going to do a show. We're going to do stuff, run stuff, look at stuff, but I just want to run through some slides that I put together. And this is hopefully a better picture than what you see when you go to the Iceberg Iceberg.apache org site and see that architecture overview of that really kind of boring drawing. It's the same drawing, but I want to talk about this for a minute. And what I did is I just made like a builder slide, and there's a lot going on here. And what I'm going to do is highlight little sections, or like put some blue code on little sections and hit on some important topics. Hey, Bert, nice to meet you. And the biggest difference in the modern table formats, and again, I think for the audience, if you know what we're about to get into, you know this, but I want to run through it, like I said, just to set the stage. And we are going to record this and post it and all that good stuff if you want to watch it another time. Is the biggest thing about the modern table formats from something like from Apache Hive's table format, the default table format, before we had the phrase table format, we had Hive, is that the metadata lives on the lake or lives on the repository along with the data files themselves. And that's a different twist than where we were with Hive. Hive, we put the data in the data lake, and we put the metadata maybe up in this, we use the term a lot, catalog now, but we used to call it a metastore, and I still often refer to it as a metastore, especially since Trino and Starburst, the word catalog means something else. So lots of overloaded words. So put the metadata, put the data together on the data lake, and we're going to get in there and see all this good stuff. And interestingly enough, Iceberg chooses this to create a layer a little deeper within your base folder where your file is, or your table is. Say maybe my table is employees. So under employees, there's another subfolder now called data. That's where they like to put the data files themselves. These are the parquets, the orcs, the avros, etc. that say, what's the records that we're talking about. And then they have another peer-based folder that called metadata. And that's really what we're talking about today. It's what we're going to see some files about, and then see some metadata table representations of those files too, because at some point they get really big and really complicated, and sometimes it might be easier. And I'll show you there's some ways to just ask queries about those files, but we'll crack a couple of them open for sure as we make changes and see what we see. Okay, what else? An important thing to note is, and we'll see this, I'll run you through what happens when we make a change, but every time we make a change, and we'll just keep it simple, we'll talk about data. I insert a record, I insert 100 records, I do a delete that modifies 1,000 records, or do a merge that modifies 500,000 records. Each one of those single statement, kind of single table activities, it can change lots of rows, but that change creates a snapshot, or you might just call it a version. The terminology is snapshot, but it is a version. The snapshot is a distinct version. We can do things with it. We can query as of that version. We can roll back to that version. We can branch from that version. We can do some other things as well. Well, oh no. I see someone saying they can't hear anything, so my hope is somebody can hear. So I wanted to pause for a moment, just get a couple thumbs up that folks can hear me. Oh, thank you. So I'm not so sure what happened to those other. Thank you. So someone can't hear, but most can. Whew. I thought it's 12:08. That would be my time. That'd be terrible if I had lost 8 minutes of your time. Okay, so as we look at the metadata, we're going to see there's a couple layers in there. There's a couple different kinds of files. The first one is called a metadata file. It's actually going to see, and we're going to pull two or three of these down, and look at those JSON files and look inside of them. But what they represent is they contain, at a high level, they contain one or more snapshots. And arguably, they contain at least the current snapshot, the current version in there. So we'll see that as we get into it. Why might it have more than one? Well, we can kind of talk about that as we go along. And interestingly enough, that catalog I keep mentioning, that metastore or REST catalog or Nessie or whatever else you got, Glue or something, it's really keeping track. Yeah, it's keeping track of a reference to that most current metadata file, saying, hey, that physical file, I know it's the one. If you come to me, so basically folks are going to query, they're going to ask the catalog, what's the most current metadata file, then they'll get a reference to it that's on S3 or Google, whatever, whatever object store you have, and then it's going to go read that JSON, and that JSON is going to say, hey, the current snapshot is. Again, like I said, we'll see that down in some nitty-gritty details in a few minutes if you hang out with me. The snapshot itself, the snapshot data, you'll see it'll reference the structure. Hey, this is the table name. Here's the column names and the order and the types and all that good stuff, any kind of partitioning, that kind of stuff. And it will also reference a specific, what they call manifest file. And that's that second tier you might see in there. It says, a manifest list. So a snapshot is pointing to a manifest list. A snapshot is pointing to manifest list. So might argue, why can't I have all together? There's some reasons to the rhyme. And again, I don't know if I'll have time to do all those. It took me some time to learn all this stuff, but I'll try to share as much as I can in an hour flat. So a snapshot is pointing to a manifest list. And you kind of see like, oh, I see snapshot 0 is pointing to that one, and snapshot 1 is pointing this one. I didn't describe why there's 2 metadata files quite just yet. Okay. And then each one of those manifest lists, it's an Avro file format, and these get a little harder. You might have your favorite Avro reader. These get a little harder to, not to download, but to decipher and look at, even with some good Avro human-based reading tools. But the data is in there. Those manifest lists are going to point to, I put here 1 or more manifest files. Arguably, it actually might point to 0. So if you create a table and you haven't added any data yet, your manifest list will actually say, well, we don't really have any data yet, so we don't have one. But generally speaking, it's going to point to 1 or more manifest files. Well, that's that bottom tier. What are those manifest files all about? Well, you can probably see it. Each one of those are going to point to 1 or more actual files. And as we walk it to the manifest file, the manifest list file, you're going to start seeing things like, as we talk about columnar files like parquets and other, most of us probably know there's lots of goodness in there, right? There's lots of ranges of things. They might be sorted. There's segments within those files. And a lot of that metadata that we think about that gave Hive really awesome help and performance when we use parquets and orcs, because the engine could read that little bit of metadata and do something with it, make an intelligent plan, for example, or just prune something, completely skip something. We're going to store a lot of that, almost all of it, or maybe more, maybe even some additional calculated stuff up higher up in the metadata. And that's going to make our system actually go faster, because it'll read these quick, smaller files and then decide what to skip and move on those things. So a little rhyme or reason as we go. Those are also Avro files. So manifest lists, a snapshot has a manifest list. A manifest list is pointing to 1 or more manifest files. Each one of those might be pointing to 1 to many files themselves. Okay. Cool news is, while we're going to go look at those files, you're going to also see I'll probably do more stuff with the stuff here on the right, the metadata table. So in Hive, we always had these kind of hidden columns that tell us things like, well, where did this data come from? What physical file and timestamps? I think there's a handful of other little metadata columns, but in Iceberg, we have this concept of a metadata table. So all those files that get, like I said, kind of hard to start looking at. We'll look at them at first, and then they're going to get kind of, let's be clear, they're going to get a little gnarly, and I'm going to go, and we're going to look at these cool metadata tables that say, hey, just tell me specifically what's going on with this version or that version, or the files that make up this particular manifest, that kind of stuff. So we'll see those in practice as we go. And in fact, let me do one more tiny thing over here. I'm using Galaxy, our environment here, and I'm going to do one thing because I'll tell you why in a minute. I'll come back and tell you why. All right, hopefully I can resume right there. DML, yeah. All right, so if those were the files, again, I think a lot of folks probably already know this because they've been exploring this and that kind of stuff, or you heard it a few ways. Let's just take a few more moments and look at some pictures, and I promise it's 12:13. That'll give us 45 minutes still to play in an editor and in file formats and all that good stuff. All right, so what happens if someone makes a change? What happens if someone makes a change? Well, actually, it wouldn't hurt to say what happens if someone makes a read. So let me just show you that one. If someone makes a read to a data table, they're going to read, again, the catalog. The catalog is going to tell them which metadata is the most current. That'll let them know the snapshot. They'll get the manifest list. They'll pull that from the object store, and that'll tell them the manifest files. They'll pull all that, and before they do anything else, they can make a lot of decisions. They know all statistics. They know roll-ups. They know a lot of aggregates. A lot of values are already present, partitions, all this stuff. And then if it's okay and need to read data, then absolutely, the engines will start diving a little bit deeper in there. All right, so that's kind of high level what's happening at read time. So high level operations of generic data manipulation language. So regardless if it's an insert, an update, or a merge or a delete statement, the same concepts are going to happen. Meaning what? Okay, so let's just level set where we're at. Here we are. We got a table, and it's got a single metadata file here that, again, just those same things we said here. No need to read what it says on the right here. Now, those that are reading it all might go, what the heck's a delete file? Okay, we'll get you there. Get you there. That's where we are. We're current state, snapshot 0. Now, what's going to happen is someone's going to do an operation. They're going to make a insert, delete, update, or something. Let's just keep it kind of simple. What if they did, hey, I want to insert 100 records? Well, what's really going to happen is, a file or a bunch of files are going to get created. They're going to get written to the object store. That's what you see down here in the bottom corner. One or more data files, it says, and delete files, more to come, are going to get written. Okay, no big deal. Everyone is still reading. They're still reading snapshot 0 because we're going to have an ACID transaction. We're going to have an isolated, atomic consistent, isolated and durable. We're going to have an isolated transaction here. And then once all those files are created, the manifest list. And this is going to happen really fast after this, right? The manifest, one or more manifest lists will be created referencing those files. A new manifest, one or more manifest files are created. Good questions. I'm going to come back, Paul, on that one if I can. Don't let me off the hook. A manifest list will be created referencing those that manifest. In this case, it depends. Likely, I just said an insert, so it's actually going to reference the same manifest files that were there previously, plus the new one. So that's what you kind of see with the arrows. The one on the left points to 2. The one on the right points to 3. So, we've got a new manifest list, and then absolutely we're going to build a new metadata file, and what we're going to do is we're going to say, hey, now we know about 2 snapshots. So we're going to keep a number of those in there. That's a configurable number, and it's not the number of versions that really exist, but it's how many will fit that we want to keep in a metadata file. And we'll just basically reference, hey, which one of those is the most important? So we say, we're all set up, reference it, but the truth is we haven't really committed this yet. And how to commit it, and I'll answer your question, Paul, I promise. 1 second here. And how do we make that final statement? Well, we're going to go back to the catalog and say, hey, guess what? I got a new version, snapshot 1. Here's the name of the metadata file that I want you to have, and we'll step away. Now, I'm going to pause there in a second, then we'll do the demonstrations and say, you might close your eyes and say there's lots of problems. I said it's atomic, consistent, isolated, and durable. Well, how do we make it atomic? It happened or not? How do we handle consistency or isolation when we think about concurrency? Well, to be honest, it's pretty simple. The model the model requires us to use an old school, been around longer than I have, and I've been doing this stuff for 30-something years. It's called optimistic locking, meaning nothing more than when this code started making these changes in Trino and Spark or whatever, Snowflake, whatever, it's going to say, you know what? I will remember when I get started where I started from. So it says I started from this file, this metadata file, 1, 2, 3, 4, 5, or even this snapshot number, more appropriately the snapshot number. And he's going to say, hey, can I make this change knowing or assuming that it hasn't been changed by anybody else? So as long as there's a consistency, concurrency of me, no problem. I'm the first one here. I can make the change. But if there were 2 of us doing the same stuff at the same time, one of us is going to win. And the other one is either going to fail, or there's some rules in the Iceberg specification of, well, you know what? Don't just fail. See if it can still happen. So basically, upfit yourself, catch yourself up to where the current version is, and see if your changes mess up the prior version. So all this is built on, and there's your question, Paul. All this is built on the concept of file immutability. And how do you make changes with that? Well, usually you build new stuff and reference new stuff. So the question Paul asked, which are all of these structures are immutable? They all need to be immutable, Paul. The actual data files themselves are immutable, and absolutely the metadata itself is immutable. In fact, that's why we have versions. We just create yet another stuff referencing what's appropriate. So once we create these files, we don't change them. We reference them and move on to the next thing as well. Hope that helped a little bit. All right, let's do some stuff. I'm going to check the chat and make sure there's not a question, and then we'll do some stuff because my stuff says let's do some demos. And I want to run this question. One more, I'll tell you why in a minute. Okay, Paul, which are immutable? Yes, yes, yes. And I think the rest are just folks saying I'm here and I appreciate you loud and clear. Great. Okay, if there was another question that got lost, I apologize in the dump, so do raise it up. Okay, I moved over to, I'm gonna just touch everything, make sure everything's still kind of not timing out. Perfect. Yay. Good stuff. All right, what I did is I am using Starburst Galaxy. Use whatever you want. Arguably, you can do this in Spark. You can do this in Naked Trino. You can do it in any engine that's going to use Iceberg. Now, what might be subtly different is when I start to do those metadata tables. The syntax of that might be a little different in different environments, but the changes and the updates and what they do on the file system will all be the same. All right. A question showed up in there. Yes, the session is being recorded, Paul. And behind the scenes, when it gets finished, an email will sent out. Thanks for coming. Probably some links, as well as tell you about the video. And I'll make sure it gets pushed out on YouTube and LinkedIn and others too. But yeah. All right. So someone else said, hey, I got a generic error. Commit failed. The base location has changed due to concurrency writes. And how do we control that? Hey, Rune, you know what you're hitting on? You're hitting on the reality that, and I'm going to go ahead and show you the slide. I think I put it in here. The reality. Oh, I didn't put it in my big course. I talk about this. Maybe I put it in somewhere. The reality is this is not a general purpose replacement for Postgres, right? This is not. Iceberg is still not a database. It acts, it smells, and tastes like one, but it doesn't. It wasn't built for the kind of high end concurrency. Now, Arun, I don't know your specific situation, but generally speaking, when you have an error like that, it's what we were just describing. Two people are racing, more than one people are doing this. They're making changes or adds or deletes or whatever. And then they both are writing all their files. And then when they're ready to commit, they have to kind of say, hey, can you update me? Is it still what I thought it was? If so, let me update it. If not, it goes, something's changed for you. And it's up to that engine. Like I said, you said, how do you control that? The easiest way to control it is don't have concurrency. And you go, oh my gosh, that doesn't make sense. It actually makes more sense than you think because these are analytical engines. They're geared around data query and that kind of stuff. And the biggest changer, the biggest modifier of data is usually that pipeline, the streaming or batch pipeline that's bringing that data to it. Now, you might have a human changing things as well. You may have to go back and do compactions. Lots of things could be the problem. But I also say if you do a good job with concepts like partitioning, that concept of what if two writers are writing and is there a problem? So, yep, I couldn't do it because I'm not the most current version. I'm not based on the most current version anymore. And earliest versions would just stop. So it depends on what version of software. It might just be stopping. But since then, pretty early days, they articulated what's different. So I'll give you an example. If it was a partition and you are updating yesterday's partition, you have a day level maybe, and you're writing to today's, then the good news is you can go, your rights, my rights, we're not stepping on each other. We're in different partitions. So it'll actually just kind of catch itself up mentally over the metadata and go, yeah, I can still write my data. So Arun, good questions. You might have a more specific, I'm the only person, what's going on? And we could talk about that either at the end or another chance there. All right, let's get into an error. Let's get into an example. All right, I keep hitting this, running this query. Why? Because I use Galaxy myself and Galaxy on the free clusters, which I'm playing with, just to keep it simple. Something you could do at no cost. We have toggled our how long it can stay not busy before we quiesce and shut it down. It's 5 minutes. So good news is now that we're here, we're not going to have that problem. All right, so I went ahead and created down here, as you see, this ice deep dive session, schema. And let's do a few things. Let's build a quick table. Create me a table. I created a table called try it with fields A, B, C, X, Y, Z, that kind of stuff. I'm at 125%, so I know it may not be perfect for everybody, but hopefully you can make it out. If not, just scream and we'll try to figure it out. And I created it. I did a describe. Yep, there's the values. And I want to say, we could do a select. I didn't do a select yet. Let's make sure our metadata is loading up. There it is. Try it over there with some fields. But what I really want to do is I want to go look at the data on S3. How do I know it's S3? I've set my schema up to do all that good stuff. Okay. Where is that going to be? It's actually going to be in this folder that I'm at on this particular bucket under Ice Dive. That was my schema. And then I have a file, a folder here called try it dash, and then a bunch of stuff. Pretty normal to see Iceberg actually use your name of your table and then some more stuff. So don't count on it being exactly the name of the table anymore. That's not the spec would allow it to do lots of things, and this allows the tables to change and that kind of stuff. What I really want to show you is, remember I said there's a metadata and a data folder. There's no data folder because there is no data yet. We just created a schema. And if I open up the metadata folder, you'll see two files. You're just going to see a JSON file and an Avro file. What are those JSON and Avro files? Well, it's this. It's a metadata file pointing to a manifest list, a JSON and a, oops, not that. And in fact, what we can do, just for giggles, why don't we go grab the JSON, for example. Let's pull him down. Select him, download him. And why don't we find it in the editor? Let's just open that guy up. And I hope I left my, I bet I didn't, Xcode Visual Studio Code. We used years ago. That would have been terrible. All right, so here we are. Here's that JSON file. Now, there are not that big. Yeah, it's only 100 lines, so we can kind of look at a lot of it. Early on, it'll be pretty small. Okay, great. What are we looking for? A couple things. We're looking for this. Hey, where is this physical file? Well, we know that because we just went and got it. Okay, that's great. But what's in here? Well, there are a list of schemas. The schemas that are in there in that list, really, there's only one today, schema. And that schema ID is 0. And the schema has fields called ID, AVAL, BVAL, and PRT. And the types are, interestingly, int, string. Pretty simple stuff, all not nullable, right? Not null. Yeah, required false. Nullable, I guess. Sorry, did the wrong way. What else do I want to see in there? So great, we see the schema that we have today. What else is there? Partitioning. So we'll look along here and we'll say, hey, show me a list of the partitioning specifications. If you remember, maybe you didn't, we actually set the table up. Where did that go to? See if we can get it back on screen here. How did I lose my... There we go. If you look back here, I actually created a partitioning right here of the field PRT. Partition PRT. Okay. So it says, hey, you got a spec that's identified on partitioning. That's neat. And, what spec am I using? I'm using spec 0. Which one is spec 0? This one. So it can actually show multiple partitioning specs. But that's the one that makes a lot of sense. And somewhere in here, we're going to see something like this, a collection of snapshots. Here they are. They start on 62, go down to 83. And if you look inside of there, there's really only one. And it's called sequence ID this. Ends with like 83,750. And here's some details about it. Who created it, what user. There's some high level stuff, how many records and all that good stuff, how many files. Yeah, there's not a lot there. What engine and stuff. And this could be different, obviously, depending on who created it. And then more importantly, once we see all that, there should be, where do I have that? There we go, current snapshot ID. So if there were a bunch of snapshots listed, it's going to say which one is the current one. It's the one we just talked about right here. We're not going to get into types around branching and all that kind of stuff. We're going to say these are basically, we're keeping on them. If you think of version control, we're going to keep it on the main line for all of us as we go here. And last thing, as I said, every snapshot has a manifest list. Well, remember what I said? The snapshot ended on 83. So right here, that snapshot actually has a manifest list. This file is that Avro file, .aov66 v5v blah blah blah, something like that. If that looks right over here. 66, there it is, 66f.avro. All right. So the main things I would say for right now, if you're first time looking at this stuff, is there's a couple important things, right? Current snapshot ID is snapshots, current snapshot ID. Where did I miss that at? Oh, right there. That's the current snapshot ID. The structure itself, that snapshot's tied, tells you the structure, tells you the partitioning specification, and then ultimately tells you where that manifest is. Nothing too hairy. I just want to pull it up and at least get us started doing something like that. All right, what else is in there? I'm going to swing back to my world of here and say, kind of cool news is some of that stuff I just heard about is actually accessible. As you remember, I said they had these metadata table files, and those are identified on our connector page. You can just type Trino space Iceberg space connector or Starburst Iceberg connector. And look at that. I rambled too much and it stopped. That's terrible. I'm going to cry, Lester. Let's see if, let me just see if this, make sure I'm not crazy. Make sure the thing is up and running. Yeah, that's going to come back in a second. That's bad if I took that long to talk. All right, 31. We're doing relatively good on time. Let's let this thing officially get started up, and then I'll continue on. I guess this would be a good time to show you what I meant here. If you go to Trino Iceberg connector and open that up, and there'll be a thing on the right that says metadata tables. So here's your docs that tell you all about what these tables are. There's a properties table, a history table, metadata log, snapshots, lots of good files in here as well. And let's see if that thing finished. It sure did. So now we can run my history. So I'm just going to run select all from history. So it's the table name $, the metadata table name. There we go. And what did I want to get out of all that? Arguably, I just want to reference that. Remember that snapshot ID that ended with 3750? The only one we have? There it is. That's the current snapshot. All right, what else can we do? There are some other cool tables like, I don't know, tell me about the partitions. Great one to run right now because there are no partitions. Why? Because there's no data yet. So there's no particular data partitions created yet, but I'll run that one a little bit later. We can say, hey, does that manifest list file name that we referenced, does that really exist? So there's a table called snapshots with more fields than I show here. I'm just listed the snapshot ID in the message list, but there's that guy, 66F Avro, as I said. Okay, so these are valid. These are reading that metadata and offering them more like table formats. And just like I had no partitions, I have yet no physical files related to this as well, which hopefully makes a little bit of sense. All right, so let's do some changes. Let's make some stuff. Let's do a quick insert, one record. Keep it super simple. Load the record one noise bogus P1 and do a quick query on it. There it is. And I would say, what do we have? Well, if we look at the S3 world, I'm going to go back up here and just drill back into metadata. I got a lot more stuff now. You're like, wow, I added one record, Lester. What happened? My metadata exploded. Well, a couple things have happened. And I'm going to download these and show you. Interestingly enough, if I look at the JSON side, those are my metadata files. I told you a minute ago that I'm doing myself a disservice. I'm reading these questions. I'm going to have to come back to your Mark one at the end here, sorry. I said when you created data, when you made a change, you made a new snapshot. So you might think, Lester, there should only be 2 JSON files here. Well, we're going to look at those, and you're going to find out what really happened is it did create a new snapshot. And we'll see if we can figure out exactly which one, because if you look at these, they're going to be so close in nature. So what I will do is download each one just to have them. Download that one. Then we'll download that one. Yeah, let's download those 2. So it actually, I'll just say it out loud, then I'll show it to you. It created a new version, a new snapshot. It created a new manifest list, which are those ones with like, .avro. And it created some, in that manifest list actually has some manifest files. That's these, M0. Those are the ones referencing actual files. And then it said, okay, cool, the rest is in the data. What happened though, because there's a few more files, I'll go and tell you, is as soon as that's done, some big improvements that have happened in the Iceberg world. There was this concept called puffin files you may or may not have heard of. And the engine said, oh, okay, there's a new snapshot and there's some new data. Let me go build some even more advanced statistics. This is optional. Engines don't have to do this, but most of them are doing it now. And actually quickly followed up with yet another update where it built whole bunch of new performance-oriented, this little stats file that's a Apache Puffin, if you haven't heard of. If you don't, it's not so important. Just let you know the engine just keeps trying to go over and over and faster and faster and better and better. So let's look at those files themselves. I think that's what I told myself to look at. Yeah, check out 2 more snapshots. I called it maybe a snapshot in half, and each one has a new manifest file. So let's just peek at those downloads. And I don't know which one is which. We'll know in a second. Here, I guess we can open them both up. That'll be a fast way. Open them up with our Visual Studio Code. Hey, someone's helping you out, Ravin. That's awesome. All right, so I got 2 files here open. Hopefully I closed the original one. Let's see if I can close it down just so I don't get lost here. Current schema ID is 0. And 663. I think that was the one, right? I'm just looking for something to cheat myself out of here. Here, I'll look at the physical file names. It ends in, oh, sorry. Okay, there we go. Hey, you know what's also kind of handy dandy? The file started with something like 000. That didn't have to be the case, but it's happening. So what happened is this. This file was created. So the schema is still the same. It says same. And then down here under the list of snapshots, if you see right here, there's a new snapshot. This is the first one, 83,750. And here's a new one, which is 1725. And if you look really closely, it actually says, hey, I'm based off of the other one, 83,750. And dig a little deeper, you'll say, hey, I added a file, I've added a record, I've got total records of 1, blah, 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 blah. And it actually has a new manifest list. This is where that other, the second Avro file, and then the rest says, okay, cool, that's what we did. And we can go look at that one and make sure, but like I said, it actually created yet one more. And here's where, and I hate to talk about this because it's even yet more advanced, but it's there. And if you really peel back the onion, you want to answer a quick answer. So here is the other one. This is the second or the third file. If you look in there really closely, it's going to look very similar. The snapshots actually look identical. Here's the original, 8350. Here's the new one, 81,725. And in fact, what it's doing, it's actually saying, hey, because I'm not really changing anything, I'm doing some additional help based on this snapshot. It's actually publishing yet another metadata file, keeping the snapshot the same and just saying, hey, I have this down here. I have some additional statistical information. This is just to make things run faster. Collision, all that stuff, it's going to fall back and miss all that. So if you've heard about Puffin files, that's what's happening there. All right, let me swing back and see where I'm at in my, hopefully I didn't let my environment die. I'm going to run this just to make sure it didn't shut down. Yeah. How long does Lester talk? We added a record. Oh, I guess I wanted to show you one more thing is are there some files? Are there some physical files that exist in there? So I'm going to ask the metadata file to tell me about it, but I'm going to drill back up to the table and look at that. There's a new folder called data. I had partitioning set up. The value of PRT was P1. And guess what? There's a Parquet file sitting here. Let's download that thing real quick. And if we download it and look at it here and look at it somewhere here, hopefully, if we open that Parquet file, open him with our good friend. Well, open him with the app we're playing with right now, which is called Visual Studio. Why is it not wanting to let me open it with Visual Studio? All right, another trick is just drag and drop it. The file names here. Oops. Having more fun than I wanted to. Cancel. Let's see if I can just drag it over here and see if it opens it. There we go. There is that Parquet file. If you look very closely, it's just a record. Now, it's not really JSON. That's just a reader inside of Visual Studio trying to help me with that. But the main point what I was trying to show there quickly was that the one record did get created, did have one file. There it is right there. It's referencing that same file. It's in partition 0. It's got a record count, so on, so forth. And the more statistics here, lots of details about that. Why? Because that file has a lot of details. You can even kind of really drill all in here. I'm going to stop just since I got 1240 already and push on. All right, so we verified the metadata happened, the file happened, all that good stuff. Download the data file. We peeked into it. All right, let's do a little more. I think I can move a little faster here now that I'm here. And I said, add a couple more records. So if I add a couple more records, I did it with one transaction. So there you see them 1, 2, 3 over there. Then arguably, I hopefully have a couple more files. It shows 3 files. We just peek, make sure data. And they're actually, each one of those files have one record in them, and they just happen to each have a different value for the partition. So you see I have different folders here, but I've got 3 files, which is what we're seeing here. And I think I asked for less columns. I just simply said, tell me the path, the partition, and how many records are in each one of those files. Again, this is not big data. This is 3 records, but it's just trying to show what's happening at a granular detail. I showed you earlier there was also that partitions. We can kind of flip it and use that tool to tell us what's going on here. Partition 1, 2, 3, 1 file, 1 record. How big is it? And if you look at each one of these, again, no need to go too far into it, but if you look at this, this is just simply, this bit of information is nothing more than basically upper bound, lower bound, null counts, that kind of good stuff for each one of those fields. Okay, I'm going to leave it at that. That's some of that it's a rolled up metadata for the whole partition. Happen to be a single file for this case, but that's okay. I'm going to look back at my snapshots table. And snapshots table is going to give you, I think there we go. I asked for it to sort it by the committed date and only tell me the current snapshot. I guess I really wanted to show you that some of that information that we saw buried in the snapshot file. There we go. There's a lot of that. How many files, how many this, that, and the other. And if we look at this one really hard, I'll just make the point. This snapshot is the newest one. What did we do? We added 2 records. So we should see that. Hey, I added 2 records. Those records are spread across 2 different files. Sure, I added 2 files. I changed 2 partitions. I got a total records of 3, so on and so on. So total data files over all 3. I got these deletes, which we haven't really played with just yet. Okay. If all that looks good, let's do another quick transaction. And this one said what? Let's update where A value is noise. So we updated all 3 records in this one. Now, this is where it gets kind of weird. Why does it get kind of weird? Well, first, it doesn't get too weird yet. I'm going to say, show me the most current snapshot. And I'm going to look at that details. And here's where some more questions are coming. I'm not losing them. I'm not losing sight of them. I just want to go on. Now, here's where it gets a little weird. When we do changes, when we do inserts, they're pretty easy. We're adding new data files. But if we do updates, deletes, or even merge statements that cause an update or delete, or many updates and deletes, those files, not just the metadata, but the data files are immutable themselves. So way back over here, we said something like, I'm going to go right about here. At the bottom, it says, hey, we're making a change. 1 or more data and or delete files are created. Oh my goodness, what does that really mean, Lester? It means the concepts that you probably heard terms like merge on read or copy on write. What it means is we really can't change files because they're immutable. So if we want to do a delete, for example, what do? We create another file, a special file called a delete file. And that delete file is going to reference what it deleted. That means later when we read next, they're going to read everything and then read the delete files and tell them what to throw away. So we're building like deletion markers, if you heard that term before. A little bit like a translog, if you think about how a database itself works. And we call that concept, by using delete files, we call that a merge on read. So we're putting the burden on the select query and the engine to go, I see what happened. I read your 1,000,000 records, but I read a delete file that says get rid of 20 of them. It gets rid of them. And to make it even worse is if we do a change, like I did there, I changed all 3 records. It changed because we can't update it. We really can't change. We can't delete it. We can't change it either. So a change really becomes a delete marker. as well as a net new add. So if we change one field out of 100 fields, what we're doing is we're referencing the record to delete, and then we're building a new add of that record with whatever's changed, but we have to carry everything forward. So that's a longer conversation. Hopefully it didn't hurt too much anyone's head, but I will say something like this. If I look really, really close, it says, what happened here, Lester? Well, you actually did create some, where's it at? You created some total delete files, total positional deletes. There we go. I created 3 positional deletes. Delete 3 of those records. I actually also, net added 3 records. And oddly or interestingly enough, I really have arguably 6 records. I have 3 records total, of course, but I have this 3 that were there, then 3 deletes and 3 adds. So it gets a little weird and confusing, but it really means I have to have, in this case, 6 files out there for us. So if we just peek in there at any of the partitions, what you see now is 3 files. Why? One file had the record. Another file, when we made a change, had to write a special file called a delete file. Then it'll be the teeny tiny one, this 1.2, well, the larger one, this 1.2K. And then yet another file that had the rewritten activity. So we pulled these down, you would kind of see all that. I'm not going to go into the delete files because we're running low on time, 46. But if we do have time, I'm going to come back and show him. I guess I should show him. Let me just show, we have to show him. Yeah, we have to show him, Lester. 1242, 42. So we need this file and that file. There we go. This will be a good example. Download, and then download that one, and then open those files up in the folder. All right, so we're going to drag these 2, drop them in our Visual Studio. Yeah, you got to see it, Lester. You're right, everybody. All right, so guess what? One of these is our original file. I wish I knew which one. I should have deleted a bunch of stuff. Let's see if this is the one. We'll delete everything, and then we'll re-add them. So I can show you exactly which one. There we go. I re-add just those 2 files. Whoops. This one and this one. Okay. Cool. This is the positional delete file. It simply says, hey, in this big old Parquet file, delete position 0. And then the other file is the net new replacement. Remember, all we did is we changed either bogus to bogus 2. I think that's what happened. And this is happening in all of the partitions. So in all fairness, we actually have about 9 files that we're tracking here. 3 in each one of these partitions. Yeah, 3 records. So yes, this is the perfect. Is this the perfect use case? Absolutely not. This is giving you an example of what's happening here. Okay. Great questions. I'm gonna save those. Keep them coming. Those that are asking the questions, if you can wait toward the end here, even if you can wait past the top, it'd be awesome. But I want to come back and do it. All right. So as I mentioned, I said there are 9 files. I can actually ask the system, just tell me what's out there comprehensively, and I talked too long. So it's going to show me 9 files. I showed you the 9 files in S3, as you see here. So when that comes up, we'll do one more thing. And I have only yeah, okay, good. We're in great shape. I just want to do some specific, simple ones here. All right, I guess while that's spinning, I'll look at a couple of my questions. Wow. Oh, generic error, working PySpark. I think someone addressed Ravinder's question, I hope. Warehouse location, is it important? It's been recorded. Ravinder, warehouse assembler scoping session, interacting. I think you got that one answered by the audience here. Scott, I see the Iceberg version in the metadata. What does updating Iceberg versions look like? Does the entire Iceberg database need? No. Good news, Scott. They're building, they want to be backwardly and forwardly, at least backwardly compatible. I guess that's a fair way to say it. Think about, is it forwardly compatible or not? It may not be. It's an old version can be read in a new version engine, but I bet you're $1 right, especially what's going to happen in version 3. There's a lot of cool low-level details that are going to happen. That's a good question. We need to come back and address I would say you're going to probably have to, unfortunately, that's not totally bidirectionally compatible. I don't think. We have to verify. But yeah, you want to get all your engines up to the latest, greatest, and then you want to start letting the code get rewritten. That's it. I hadn't thought about that one today. Good question. All right, so I'm back and running. There's my 9 files, as I mentioned. If you look, partition 111, there they are on the right. Partition 222, 333. There's my 9 files I did. All right, I also said time permitting. I guess I thought I was out of time, but looks like we'll go ahead and run this one. This just says, hey, what if I do another update? Change B value from bogus 3, from bogus 2 to bogus 3, and then I added a condition, right, where it was bogus 2, but I also added a partition 2. Really, all I want to do here, there's no magic here. If I looked at this and I went over here in the system, if I looked at partition 1, I still have 3 files. If I looked at partition 3, it would be the same, but the one I changed was partition 2. And the main point I wanted to say is the good and the bad news is absolutely try to reference, partitioning in your conditions if you know you can go there. So the engine doesn't have to work a little bit harder and go hunt everything down. So again, good partition strategy always still makes a lot of sense. But if you're, if it's potentially everywhere and you need to update it, then obviously do what you need to do. I think that's really what I wanted to kind of show in there. All right, what did I have here? What else? There's the Yep. I guess we don't need to walk through this, but this is what just happened, all those different steps, so on and so on and so forth. 11 files out there. We could look. Y11, we had 3 and 3 and 3. That was 9, but then we did what? We changed one more record, so we'd create another delete and then yet another kind of re-add on top of that. Now, I would say that's a good place for me to stop doing demos, answer questions and that kind of stuff, and tell you about some additional things that you can research that I have and other people have. And it would be around kind of what you see there. Maybe I'll just pause and read the questions. That might even be the better answer here real quick. Okay, so while we're doing questions, let me go to the bottom and say, listen, there are this information with a little more color. I was hoping to, replayable this video plus that blog would be good walkthroughs if you're going to try to create some of this yourself. But I have a few more articles out there that are coming to the Starburst IO website. They're actually on my personal blog, lestermartin.blog. If you want to peek ahead of time and go find these, you can just search on the bottom. Go find the tag that says Iceberg. You'll see some of these titles. They might be a little different, named a little different, but we go in a lot more difference detail. We're going to go down like what happens when you create a version from a previous version and roll back and all that kind of good fun stuff, and really play with it and learn a lot of good scenarios like that very bottom link says at the bottom. Hey, snapshots are really not affecting performance. They're affecting storage. You have to kind of either get there on your own, think about it, or read my video or come talk to me a little bit more. So that's what's next. That's where we're coming next. It is 53. I am going to glance at these chat messages. Hey, Jen, you're out here. Thank you. And let me see if I can address most all these. Okay, so I saw Scott's about Iceberg version. I have to think about that one, Scott. I apologize. And then, Arun said, updating the Iceberg versions only at the writer side. You don't need to rewrite the data. You just need to update it. That's a fair way to look at it, Arun. But I think once you rewrite that metadata, like in version 3, where they have like file, row level metadata of transactions, that may not really work in an old engine without the new version. So that's all I thought about on the fly there, Arun. But you're spot on. Is Starburst DCAM or CDMC or ADAC compliant? Whoa, Neil. Type some of those out for me. Help me out here, brother. Remind me, I feel bad for having a tough morning there. Sounds like those are some standards compliance bodies that my brain's not hitting. So maybe Neil type a few things in there, or we can go to the Starburst IO site and try to help that down. Like everybody, we all have a certain level of compliance to sell to folks like federal governments and others. Maybe that's what we're talking about there. How come it doesn't degrade performance over time? It doesn't degrade performance over time for this reason. If you look at this and you think, what if I've got more and more and more and more of these? It doesn't degrade read performance because every time someone reads, they're going to go to the catalog. The catalog is going to point them to a single metadata file. So if I've got hundreds or thousands of metadata files, who cares? I'm just going to go to the most current one. And then to be honest, I'm doing a read. So all I really want to get out of there is the current snapshot, which has a schema. It has a list of a manifest list file. Regardless of how many of those exist, I'm going to only go read that one. And then that one's going to reference more and more. So yes, you can say, yeah, the bigger your table gets, the more data, that's going to affect performance. But how many versions you have really doesn't matter. You just have a lot of metadata sprawl out there that has another problem. A lot of references to older files. We haven't talked about things like compaction here today. There's lots of cool tricks that are going to happen for us to kind of rewrite these files. That builds new versions, et cetera, et cetera. So I hope that helps a little bit with a high-level question. Why won't it affect performance? That was the rough answer. Like I said, I got a blog post specifically on that, lestermartin.blog, if you want to get to it a little bit early. What questions did I have now? Is there a compaction logic when the whole point of structure becomes? Yeah. Hey, Paul, the good news is that it's called compaction. The good or the bad news is by default, it isn't something that Iceberg itself takes care of for you. But every vendor has, including us, has some mechanism if you want the tool to take care of compaction for you. That just simply, and compaction is a longer story, but you're asking the question so you understand it. I think for the small tables, which is 80-90% of the tables are not very big and small, letting that be automated is a good answer. I think for the gigantic tables of velocity and volume and all those V's that we learned years ago, big data, I think the data engineer probably knows best when we ought to do that. And it's not just compaction. There are other things like expire those old snapshots. So we can roll versions off and things like that. So yes, absolutely all that exists. And there's strategies and tools around that. Does Starburst have a REST catalog endpoint that's compatible with Apache's open API spec? So I think the answer would be, does Starburst have a Iceberg REST catalog? And then is Iceberg REST catalog open API? That's another conversation. I would say today we don't. I used the word today and I didn't say anything else, so I don't think my product management team's going to come hit me on the back of the head. But I'll just say, as a lawyer, it would be nice if we had our own. In fact, if you and me want to start a company, I would go start a catalog company. And in fact, one or two other people have already started those, because the war and the fight is around the catalog. But we don't have one today. We have our own metastore, but it's not publicly exposed. You have to use Starburst to use our metastore today. Leave it at that. All right. Arun, is there other table operations like rewrites, data files, absolutely. All those things you know about and you hear about, those exist as well. Go to that connector page that you see on my tab. I'm pointing on my screen that you see on my tab in the upper right-hand corner to see the current ways we initiate those. Right? Spark's going to have a different function call than us. That's okay, but they do the same thing. Absolutely. Is the delete marker reference when the new snapshots are created? No. Part of that part of that compaction is to clean that mess up too. We want to just say, nobody wants to do a merge on read. We do merge on reads because we don't know how much change are going to happen. A copy on write always, which is where like Delta started with. Now they do a merge on read concept too now, and even Iceberg supposedly as a spec lets you do both. In Starburst Trino, we still only do merge on read. Maybe someday we'll allow copy on write, but we don't do that. So yes, not when a new snapshot is created, but when a compaction of files occurs, that's when we'll clean up those deletion markers. Is it possible to apply quality deletes? Absolutely. So those deletes files are types of, and the current ones are positional, like you saw, that reference specific records. They could reference ranges too, like 0 to 1,000, but range records also exist as well. I mean, quality. They can say things like where the state they live in the U.S. is, Georgia. There's some rhyme or reason why some people feel the quality deletes are terrible, but there's going to be something different in the future. In version 3, it's going to be like row level delete tracking. But yes, there's different kinds of delete files. that makes sense. Yes, if you're going to turn over 90%, you are just doing a quality delete. You don't get to pick, the engine does. It says we're finished, but so if you got to run, I understand. I'm going to hang around to answer these questions before I sign off. Another question, if you have time, what are good implementation options that will batch writes together, limits the amount of rows? Yeah, Scott, great question. Last year's Iceberg Summit, not the one that just happened a couple weeks ago, but the year before that, for sure, there was some really good presenters that showed in their world, they were purging snapshots very quickly. They only had a couple hours worth of snapshots. So these are all going to depend, and you're absolutely right, how fast your data comes in, how fast you need it available. And it's a lot of things. It's not just the snapshots, as you said. It's sometimes it's really, especially streaming data, it's going to be that we write too small of files. So we have a streaming ingest our own that pulls from Kafka, and it's going to run pretty fast. But when we do those, we also automate compaction as well. So my feeling is on the highest volumes, the data engineer does need to get involved. They really, really understand a little best and a little better. And there's going to be some trial and error to find the right numbers. But tooling like S3 tables, for example, they're going to say, you don't get to do it. We do it. We make those decisions for you. So yes and no. All right. That was a good one, Scott. We can come back and have one-on-ones, of course, about this. That's the problem. So Brune said that's the problem, but these are not bad problems in my book. These are problems we had a long time ago with Hive. At least we have transaction controls for the compactions, which we didn't have a problem for. All right. So Scott says things. Enterprise Data Management Council standards, Neil. I don't know, Neil. I really don't know that answer. I'm leaning toward maybe not, but please don't quote me on that just yet. You can reach out to me, Devrel at Starburst.io, or comb our website or something, and we can get you an answer to that. And then the last question I see is also from Henry. Best practices for using Iceberg tables as a source for local debugging. Pulling the table in the debugger via IntelliJ or around catalog requirements. I don't know, Henry. I have to think about that one. Local debugging, Iceberg. I don't know if for local debug, I have to think about that question, but it sounds to me that the amount of data we're trying to look at, probably maybe we're using it's rough look looks like we're using a bigger hammer than our nail needs. So maybe we need a push pin, but maybe I just don't know exactly what you're doing yet. So Henry, we might have to reach out to me. You guys can find me on LinkedIn as well. Love a good connection or just a message out there. And I am thinking, I don't know if I answered them all perfect, but I think I hit all the questions. I got 1:02 on the clock. Got Jen in the background backing me up. And I think I'm going to leave the stage and shut her down for the day. So I thank everybody. There are a couple more blog posts coming. Reach out to me directly on LinkedIn, on our corporate site, wherever you can find me. And if you want to pre-look at those 3 additional blog posts that are coming, they're just ports to our corporate blog. Like I said, you can find them at lestermartin.blog, lestermartin.blog. Thank you all for your time. And thanks for those comments at the end there, Paul, Rune, others. I really appreciate y'all. And happy Iceberging and happy metadating and happy Trino. And hopefully talk to y'all soon. Bye-bye.